Hello everybody and welcome to module 4. So in previous modules what we have done is we looked at specification based testing, and in module 4 we are looking at the second part of it. Now in the second part, as a part of the 4 subtopics, what I would like you to do is to get knowledge of a systematic method of doing something. We looked at equivalence class and boundary value analysis in our previous module. Now we'll look at another systematic way which we call as category partitioning, and we're going to do a mix and match of problems and the techniques that we can solve with this method. So just a quick recap of what we are going to look at in this particular module is 4 topics. The 4 topics are domain testing, that is what we'll look at right away. Then we look at very interesting 2 subtopics, which is combinatorial and then decision table based testing. I think these two, along with equivalence class and boundary value, will form that solid foundation that we need for software testing techniques. And if you recollect our diagram in which we looked at the entire base of mathematics and the problems and the concepts based on which we had the techniques based on which we were able to apply them, I think now you can relate with how we are trying to make the foundation much stronger. And of course, as usual, we are going to look at and discuss a lot of examples. In fact, through my sessions, you would see that it's not that we look at examples only as a topic, we'll look at examples in and around us. And in fact, I'm in a new wonderful studio this time. So we're going to look at one example which I built up while I was looking at the new studio. So I think that's something that we would have. So as a part of 4.1, I want us to look at the entire concept of black box testing. So we looked at black box testing, which we also called as specification based testing. And this is a slide from our previous module, is where we want to look at the whole piece from what goes in and what is coming out. So it's an input output based mechanism. And we look at functional, we look at behavioral, and we look at how the system really performs for various inputs that we provide. What's the outcome? Desired, undesired, required, not required, expected, not expected, implicit, explicit, various types of it. And why we call it black box? Simplest of the examples is that the multiplication or successive addition are 2 mechanisms to find a square, and we could use any one of them, but we are not going to worry about how the whole piece is done inside this particular box. So this whole thing remains as a black box for us. And then our view is also going to make sure that we want the system to be working at the end of our exercise, and we want a system that works. Various perspectives specifically that we are going to look at is of a development engineer today, as well as customer and client, and that of a architect. These 3 perspectives will be predominant for us. However, you're free to consider many more perspectives based on the field that you work in, based on the domain that you work in. So if you're working in healthcare, a perspective of a doctor would be very different than that of a technician. And of course, we have looked at many examples. These are the examples that we have looked at. I would like us to extend our thought process into specifically 3 more examples, and I'm going to take you to those. Let's look at this. This is one example which is to do with something to do with GPS, positioning. We look at cartography, and the diagram that I'm using for us to learn is out of Wikipedia. Wikipedia and Wikimedia, from where we will be able to get some amount of information. This is a very generic example. This has been existing for decades together. In fact, I would say thousands of years, which include the explorations of various explorers around the earth who were traveling in their own ships, either sea or they were traveling on horseback. In those days, where navigation existed, to today's modern navigation systems which allow logistics to move from one place to the other. So here you can see you have a truck there, a GSM GPRS connection, a high-tech connection. You have a GPS system which allows finding the location of that particular truck. And then this could be put onto the map where there is cartography. So there is someone who has collected and digitized the maps, and we will be able to place this particular icon on the map and a push pin which allows us to say that this particular truck which is going from point A to point B is at a particular location. You can imagine that such a system is a very, very complex system. Many entities, many systems, many machines involved. And of course, if I may call it, there are way too many moving parts as well. There are real-time components, there are heavy processing components, and it becomes a very, very complex system, but very, very useful system. So this is one. Let's look at another one, and I hope I get to it. Yes, a very simplistic example again, which is a bike, and we have a solar powered electronics which is used to track and account for the usage of the bike. Now, wonderful, if I'm able to look at the location of the particular bike by having a GPS receiver, like we did in the earlier example of fleet management, plus the number of miles, at what speed the bike was being taken, on what kind of road. If I have those number of sensors which are put up on this bike, I'll be able to find out what kind of terrain, where was this bike really taken. And of course, I would have timers and time to keep track of it. So look at such systems, very realistic, very day-to-day systems. And if we look at it from a software testing perspective, how do we go ahead and test becomes our major area of interest. So coming back to our example again, a coffee machine, a ATM or a washing machine, they do provide us day-to-day examples, but we'll also now scale up our thinking to very large systems. And when we're looking at very large system, a systematic way of thinking becomes extremely important. Thus, just looking at equivalence class partitioning or boundary value analysis, valid and invalid subdomains that we learned may not be enough thinking tools to make it happen. And typically, when it is left to only thinking, then the steps may or may get missed, or there is so much of innovation and creativity that then consistency may be lost from engineer to engineer. Now, while we do not want to lose the creativity, we also would like to bring in a lot of probability of success. Now, these few statements would imply that we are going to talk about a process. We are not really going to talk about a high-level process, but we are going to talk about a method that we are looking at, and we are going to call it a category partitioning method. So what is this method? What are we really doing over here? This is about a systematic division of tasks for larger systems. And of course, we want to make it iterative. So we'll be able to go through this over and over again, till we refine our test suite so that we achieve what we want to achieve. Now, before I begin and go through the steps, I would like us to look at the diagram which is in the textbook. I think that will give us enough amount of visual detail in what we are going to look at in the next 15-20 minutes. So let's look at that diagram. So on your monitor, what you should be able to see is a diagram which shows this category partitioning method. And before we get to category partitioning method and the details of it, let's look at how it is really distributed and divided. So it's distributed and divided into 8 steps. Now the 8 steps that we are looking at, I'm going to read them quickly, is we are looking at analyzing the specification, we do the identification of categories, we partition the categories, then we are looking at identification of constraints, and on the right hand side from 5, 6, 7 and 8 we actually get into the process of writing the test specification and then the test cases. We get to test cases, test scripts, test specification. So one of the unique pieces in this particular process, 8-step process, is, in my opinion, a focus that needs to have on the categorization, on the choices that we make and the constraints that we put. I think this is where a lot of engineering goes in from a test perspective. And this category partitioning method as a tool will allow us to bring in tremendous amount of effectiveness for equivalence class partitioning and boundary value analysis. Now, why only limit to equivalence class and boundary value analysis? In fact, we are not going to limit to equivalence class and boundary value analysis alone. I'm going to extend this and make use of it even in our decision table based testing, which is going to be done in this module itself. So we'll treat it as a systematic process, and we'll also make sure we make use of it beyond what it is suggested right now, and we'll be able to do that successfully. So starting point here is the specification, and the end result out of this whole process or steps is going to be the generation of test scripts. That's what we will have. And the intermediate step, we have to make a bunch of choices. We have to allow us to get into application of constraints. One way to look at is how much of this process can be automated. That is one question that I have always got. And in today's world, instead of doing things manually, we also would like to have things done automatically. So you would see that there are these boxes, which are the boxes which are solid boxes. All the solid boxes tasks are to be performed manually. Now we will also comment on, can some of this be done automatically by applying some of the algorithms. And we are not going to go too much detail in each of the steps, because then it becomes prescriptive rather than the creativity that would be allowed from a domain perspective. So as we already mentioned, it's a systematic approach, and it's a mix of automated and manual steps. And for reference, you should look at the text 2 and section 3.5. That is where our references, which we just saw a few minutes ago on the document camera. So these are the 8 steps, and let's start going deeper into each of the steps to an extent where we understand the process. So first one is for us to identify the functional unit. And here we are looking at identifying the functional unit which can be tested separately. And for larger systems, we would want to break this down. Now let's come back to our example where we were talking about a coffee machine. Now if you're looking at a coffee machine, would we really want to break it down into subsystems? Let me get to a coffee machine now. We have a coffee machine here now, and would you now want to break it down further? Probably not. Coffee machine in this case, which is the Georgia coffee machine, we would probably not break it down further to test the subsystems. But how about looking at our system, which is the system for fleet management? I'm very much sure that we would want to break it down. Break it down into system that is in the truck, system that is the GPS system from a receiver perspective. There may be processing system which collects the data from the truck in terms of vehicle management, telematics data. or a system that is actually going to just collect the data and dump it onto the internet and then onto the server. So a lot of these systems could be broken down further because this is going to be a very, very large system. And even if we are looking at one truck right now, we are looking at managing a fleet. How about the example where we looked at the bike? Now, this is a semi-complex system. We may or may not break it down. But one of the choices would be, yes, let's break it down, because breaking it down will allow us to narrow down the area and focus. The more narrower we create, we will be able to go deeper. But beyond a certain point, things can become brittle, and you do not want to break down just because the process tells you to break it down further. So a unit that will become useful for testing. At this point, it might make sense to put product testing in perspective over here from a breaking down perspective. So if I move back to our slide, breaking down into subsystems would be useful, and I'm looking at a product line right now. So if you look at a product line would be straight single platform multiple feature products. Say we have a product line which is a coffee machine. So coffee machine features would start increasing. A coffee machine that takes input which is pre-processed tea mix as well as a coffee mix versus fresh beans. Now the system that mixes water, heats water may be a subsystem that would be common across the product line. Now when I know that I have an entire product line to test, it would be important to break this thing down. Break down to the level that it becomes useful for the entire product line. Not break down because the system or the process allows us to just take an option of breaking it down. Break it down for a purpose. And you would, going down the road in further modules, you would also see we are going to look at integration and system and subsystem testing, where I think putting things together back and testing also becomes a key factor. So you start putting one and one together, and that is when you look forward as well before you start using this process. So though it just says break down the system, you now can realize that there is a lot of responsibility of how you break it down and what's your purpose for break it down. So definitely make sure that you ask these questions about the how and the what. Again now, identification of categorization, which is identify categories, which is for each testable unit. We're going to analyze the specification and isolate the inputs. So if you look at coffee machine, our coffee machine is going to have inputs. What are the inputs to a coffee machine? If it's a premix, yes, there has to be enough premix of tea or coffee or probably lemon tea. And then there are going to be inputs in form of buttons, which are provided by the person who would like to have the cup of coffee or tea, as well as other inputs that come in terms of electricity that is required to run the system, a heater that is required to heat the water, as well as provision of water, which becomes the input to the system. Thus, each of these systems, each of these inputs form those inputs which are required for that testable unit to run. And many a times a testable unit, just because it can be observed differently, may not be broken down differently, because the system will have to be tested as a whole. So this is, in this particular phase, we break it down, we understand what parameters we are looking at. Say for example, we are looking at a shopping cart. And a shopping cart, you may have number of goods, weight of goods, size of goods. So each of these become categories. Each of these become parameters within the environment of that particular problem, and they become implicit or explicit characteristics. A cool UI is an implicit characteristic today. No one specifies that we require a very beautiful UI, a UI and user experience. Or error handling is an implicit requirement. So those are the categorizations that we need. So now you look at it that it is beyond just the equivalence class and boundary value analysis. We are looking at it from a spec perspective. So it goes at a higher level in our order of thinking. Partitioning the categories. Partitioning the categories is one of the pieces that we would do fundamentally in equivalence classes, valid and invalid subdomains. Okay, so valid, invalid subdomains, anything more that can be done in partitioning. It may be domain specific, but valid and invalid subdomains, correct values and incorrect values, those are the choices that we would like to make. Over and above this, there are many things that become available as a part of certain choices. Let me explain what I mean here. In a coffee machine, we make a choice that we would like to have lemon tea when it is premix. Lemon tea in premix may not be available with or without sugar. So the moment you make a choice, you have actually made forward choices. Choice for the next step for sugar doesn't exist when you make one choice. When another choice happens, which is like tea or coffee, say sugar can be added separately, which becomes a choice. So each of these cases become a matter of taking decisions. So at a particular state, the choices differ. You start making choices. After you have made the first choice, then a set of choices become available. You remember if you have called up a credit card calling number or a bank number which does phone banking, you will find that there is first level of menu and second level of menu. In fact, first level of menu and second level of menu even exists in applications like Microsoft Word. But then that's the piece that we start looking at, that you have made the first choice of you want to look at the file options and then probably print. Maybe your coffee machine has your favorites. I'm yet to see one, but typically in corporates, I would love to have a coffee machine that if we have got 50 employees and we would want to have each one store their preferences. I needed this light, that strong, with sugar, with X amount of sugar, and the person just comes and punches a particular number. Say my number is 1258 and I just punch in 1258 coffee and it gives me that option. So there are those pre-selected choices which are made. Once that is done, where do we get to? We get to constraints. And based on those choices, based on those combination of choices, we will be able to get to certain constraints. Certain constraints which identify possible and not possible combinations. The moment you have made a choice, that leads to a possibility or not possibility of certain options. Disabling of certain buttons. On one of the serial terminal emulators, all buttons get enabled only after the connect button is pressed. But the moment the connect button is pressed, the connect button itself gets disabled, others get enabled. But when the connection is lost, others get disabled and the connect becomes enabled. And connect and disconnect could be on a single button because they toggle. You're not going to disconnect till you're connected, and when you want to disconnect, you better be having a connection to begin with. So that's how choices would become different. But till this point is when it all remains under the purview of how we start thinking. So as we looked at again, let's move quickly for a snapshot to the document camera, and we will see the diagram again. And what we have noticed is these four steps that we have on our left hand side, which I'm showing with a pencil. On to the right, what we have is all to do about test cases. That's the systematic approach that we are all aware of all the while. So this piece that we have looked at, this process, is what we should consider carefully in the domain partitioning method. And we'll start applying this in our next topic in this module actually. So let's quickly go back and finish off our understanding from step 5 to step 8. So step 5 to step 8, I intend to go a little quicker, and now we'll go from step 5 to 8. In 5 to 8, what we're going to do is write or rewrite the test specification. So the whole piece is, we are in a world where we want to iterate. We will go in steps and we will iterate. But we look at it this way, that we write the test specification first. What is it that you intend to test? Specify what needs to be tested, like the requirement specification. And the next step would be the process specification. And what we are looking at is an entire test frame to be created, which allows us to create a test frame from which a test case will be derived. So you spec it, frame it, and then you get into deriving the actual test case. And we'll look at it as an example when we go to the decision table based testing. Then, when you've got all these test frames, so a test frame to figure out the outcome of pressing a certain set of buttons on a coffee making machine. And then we realize that there could be redundancy in some of them, or there could be missing cases. I may focus on getting tea, coffee, and lemon tea. I may have to focus on getting tea with sugar and coffee with and without sugar. So we've got to look at redundancy. In fact, many a times you would find that there will be certain amount of redundancy between the steps. Like a withdrawal of money as well as checking of the balance initially requires you to have logged in into the system. So logging in, if I take test cases end to end, logging in becomes a redundant procedure when I look at the test suite. If at all my test suite is made up of 2 or 3 test cases, which first step is logging in. But we like it or not, we will need to do those operations. And especially in ATMs, many a times they expect you to do only one operation end to end. The moment you want to select another operation, it actually logs you off and you got to use your card again to log in. So depending on the domain and depending on the procedure, we got to look at what becomes redundant and what becomes the missing test case. And it's an iterative process. We like it or not, it's going to iterate. And it's better to iterate. So we improve every time. Then comes in is about generation of test scripts. We typically get, say, logging in becomes my test frame, and then I get a bunch of things that I can test with. So logging in with an ID, logging in with an email address, then password, type of password, all the screens that I need within that, number of tries that I can make. Maybe after the third try, my account gets locked for 30 minutes, or probably it's blocked till I unblock it by calling somebody. So various things could happen, and test scripts will need to be generated. Now you can imagine that the moment I have got certain frames, certain logic, my test cases and test scripts could be generated automatically. I also would like to think about automating a lot of processes. Like for example, menu. I have created a menu tree. The moment I have got a menu tree, I'll be able to iterate maybe depth first or breadth first, or a combination of both, or randomness into accessing the menu, so that I'll be able to generate and use the system like a very typical user. A proper use case would mean that I have for a editor like Microsoft Word, I would invoke it, create a new document, edit the document, save the document and close the document. Becomes a use case. In this, certain menu structure gets tested. Whereas if my focus is just test the menu structure, what would I do? I would just let my system wild in a test frame and say that test out all the options, all the possible options and all possible mechanisms. So first it opens up a document and then somehow goes and changes the format, then it looks at a view, or it inserts some object based on not what we are trying to do in the document, but based on what my menu or what my focus is. So you can see that first 4 steps where we made certain choices, applied certain constraints, and looked at what environment allows me to do. And if I now look at it from a product perspective or from my system or domain perspective, then my generation of test cases 5 through 8 will have a very, very peculiar focus, specific focus to come up with those test cases. So that's the 8-step method. Very crucial, very important 8 steps. In fact, over many years, I've been using such steps. When I was a test lead on a project a decade ago, as well as today when we look at various projects, this is the kind of thinking that goes in. And the more we think of it in a systematic manner, which this 8 steps provide, the probability of getting the best test scripts for the problem at hand increases. So that's what we had to cover in our 4.1. I hope you enjoyed it from a process perspective and also would be able to apply it for the problems, and not only to equivalence class and boundary value analysis, we will also apply it across the board throughout our software testing methodologies. And not only that, I strongly believe it is useful back at work. Thank you.